Hi everyone. Welcome on this lecture series on digital signal processing. In my previous videos, we have solved some examples on Z transform. Today in this video, we will take some more examples on Z transform of sequences. In one of my previous videos, we saw that Z transform of this sequence half to the power n un is 1 upon 1 minus half z inverse with ROC mod z greater than half. And we also worked out another example which was minus half to the power n u of minus n minus 1, and z transform of this was evaluated and we obtained 1 upon 1 minus half z inverse with mod z greater than half. Now, can we generalize this to examples? Generalize means what? Here I have taken half. Instead of half, if I take alpha to the power n un, where alpha is any real number, 1, 1 by 2 or 3, alpha is real. May be complex, it may be even complex. Let's say e to the power j3n. And then if I ask what is the Z transform of this sequence alpha to the power n un, where alpha belongs to complex number, set of complex number. This C script denotes set of complex numbers. And similarly, if I generalize this second example and if I ask what is the Z transform of minus alpha to the power n u of minus n minus 1, what it would be when alpha is not half, when alpha belongs to C, any complex number, then what would be the Z transform? So the process would be the exactly same, but there is a one important point which we should note, and therefore I will solve these examples. So let us say now sequence is alpha to the power n un, means it is alpha to the power n for n greater and equal to 0, and it is 0 for alpha less than 0, where alpha belongs to set of complex numbers. So from the definition of Z transform, the definition is summation over n from minus infinity to plus infinity x of n z to the power n. This summation would be from 0 to infinity, because sequence is non-zero only in the duration, 0 to infinity alpha to the power n z to the power n, and which can be expressed as n from 0 to infinity alpha inverse z to the power alpha inverse this can be expressed as the following: summation n running from minus infinity n running from 0 to infinity alpha z to the power minus 1 whole to the power n. And if you expand this, you will get 1 plus alpha z inverse plus alpha z inverse squared, and so on. And again, this is an infinite GP, and the summation of this geometric progression would be 1 upon 1 minus alpha z inverse, provided this common ratio, which is alpha z inverse, if its mod is less than 1. So our common ratio is alpha z inverse, its mod should be less than 1. So we get mod of alpha upon mod of z less than 1. Or we can say mod of z is greater than mod alpha. Remember, this is greater than mod alpha. It is not simply alpha. So we have worked out z transform of the sequence alpha to the power n un, and its z transform is 1 upon 1 minus alpha z inverse mod z greater than mod alpha. Now if you compare this with our previous example, half to the power n un, whose z transform was 1 upon 1 minus half z inverse mod z greater than half. So where I have made changes, here you see that this half is replaced by this alpha, and this mod z greater than by half, or you can say it is mod z greater than mod half. So mod of half would be half only. So what I have done, this mod of half is replaced by mod alpha. Now on the same lines, if I ask you what would be the z transform of the sequence minus alpha to the power n u of minus n minus 1. You already know the z transform of this sequence minus half to the power n u of minus n minus 1. And what it is 1 upon 1 minus half z inverse with mod z less than half. Now instead of writing half, I will write mod z less than mod half. So from analogy, what would be the z transform of this sequence minus alpha to the power n u of minus n minus 1? It will be 1 upon 1 minus. This half would be replaced by what? Alpha z inverse. Now what would be the ROC? Mod z is less than what? Mod of alpha. Here alpha was half. So now we have generalized these two examples. And again, it is important to note from these two examples that this sequence 1 and this sequence 2, these two sequences are altogether different, but their expressions for Z transforms are exactly same. What they are? They are 1 minus alpha Z inverse. But where is the difference? The difference is in their ROCs. Now, if I draw the ROCs for the first sequence, what it is? This is the Z plane, and ROC for the first sequence is mod Z greater than mod alpha. So I have to draw a circle of what? Radius of mod alpha and centered at origin. And ROC is greater than mod alpha. So it would be the exterior of the circle, this circle. This is for the sequence number 1. This is ROC for sequence number 1. Now similarly, what would be the ROC for this sequence 2? So here again, this is the complex plane, and here I draw a circle of what? Circle of radius mod alpha. But this time mod z is less than mod alpha. So ROC would be interior to this circle. Now we will take one more example. Let's say x of n is the following sequence. X of n is alpha to the power mod n. And there are two possibilities. One thing, alpha is, let's say, real. It could be complex, but for the sake of simplicity, I am taking alpha real. And then there are two possibility that alpha is, in the first case, is strictly less than 1, and in other case we will see when alpha is greater than 1. So we will take both cases one by one. Now if you express this sequence in two pieces, one for n negative and one for n positive and 0, so what you can write? You can write it is mod, it is what? Alpha to the power n. So mod n will be n for n positive and 0. So alpha to the power n for which range of n? For n greater and equal to 0. And in the negative side, this mod of n will be what? Minus n. From the definition of mod x. What is mod x? Mod x is x when x is positive or 0. And it is what? Minus x when x is less than 0. So what I can write? It is alpha to the power minus n when n is strictly less than 0. So this is the piecewise representation for this sequence alpha to the power mod n. Now, can I write this xn in terms of familiar sequences which we have just worked out? So this first piece can be written as alpha to the power n un, and the second piece can be written as alpha to the power minus n u of minus n minus 1. And we have already worked out the Z transforms for both the sequences. So can we write Z transform of this sequence xz directly? I further simplify this sequence and write like this. It is alpha to the power n un, and it is plus, this second part is equal to 1 upon alpha to the power n u of minus n minus 1. So what would be the Z transform of this sequence, which is summation of two sequences? So this is our sequence in terms of two sequences. And we already know the Z transform of both the part. What is Z transform of this part? I mention it in red. It is 1 upon 1 minus alpha z inverse. And here there is slight change. We saw Z transform for minus alpha to the power n u of minus n minus 1. And Z transform of this was 1 upon 1 minus alpha z inverse with mod z less than mod alpha. So what will be the Z transform of this part? It will be minus. Why minus sign? Because here minus sign is there, but here the minus sign is absent. So to accommodate that, I have taken minus 1 upon 1 minus alpha. Now this time our alpha is not alpha. It is 1 by alpha or alpha inverse. So alpha inverse z inverse. But these both components have different ROCs. This component has ROC mod z greater than mod alpha, and this component has ROC what? Mod z less than what? What is here? Alpha, actually 1 by alpha. So mod z less than 1 by alpha, mod of 1 by alpha. Now because I have taken alpha real, so there is no need to put these mod signs here. I can directly write xz is what? 1 upon 1 minus alpha z inverse with mod z greater than alpha, and this part can be written as 1 minus alpha inverse z inverse with mod z less than 1 by alpha. Now you can assume, let's say this alpha is half. Assume alpha is half. Then what would be the Z transform? So means our sequence is what? Now the sequence is half to the power mod n. If I take alpha half. So this would be the Z transform. But now it is important to verify that this both for which range of R or for which range of mod Z, both these two sequences are converging. And both these two sequences would be converging in the region where both the sequences are simultaneously converging. But suppose this sequence converge and this does not converge, then xz would not converge. So for convergence of xz, it is important that both should converge together in some region. So is there such a region available where both these two parts are converging? So we draw the ROC in complex Z plane and we see whether we are having some region where both the sequences are converging together simultaneously. So I have to draw a circle of what? Radius alpha. And since alpha is, I have taken half, so I will draw a radius of, I will draw a circle of radius half. So this is the circle of radius half. And for the first component, the ROC is greater than half. So this exterior of the circle is the ROC. And for the second component, the ROC is mod Z, what? Mod Z less than 1 by alpha. And alpha we have taken half. So it will be what? Mod Z less than 2. So I have to draw a circle of radius 2. So I have drawn this circle of radius 2. But what is the ROC? ROC is less than mod 2. Mod Z less than 2. So what would be this region mod Z less than 2? It would be the interior region of this circle. So this is the interior region of this circle. So do we have a common region where both the components are converging together? So answer is yes. What is that region? That region is this annular ring. This annular ring between the circles of radius half and 2. So this is that annular ring. This ring, or the ring where both the colors green and red are coming together. So we have a common region, mod Z greater than half and mod Z less than 2. So in this case, when our alpha was less than 1, or in fact when we took alpha half, we have the Z transform, which is the following: 1 upon 1 minus half Z inverse minus 1 upon 1 minus 2 Z inverse with ROC mod Z greater than half and less than 2. Now what happens if alpha is greater than 1? So again, let's say alpha is 2. For the sake of simplicity, I take it 2. So what would be our Z transform in this case? So I first write this xz. What is our xz? In general, it is 1 upon 1 minus alpha z inverse with mod z greater than mod alpha, and minus 1 upon 1 minus alpha inverse z inverse with mod z is strictly less than 1 upon mod alpha. Now our alpha is 2. So taking alpha 2, what would be the Z transform? Xz would be 1 upon 1 minus 2z inverse. And what is the ROC for this part? Mod Z greater than 2 minus 1 upon 1 minus half z inverse with mod Z less than 1 by 2. Now, what would be the ROC of XZ? We have to check whether we have some common region where both the parts are converging together. This part converges for mod z greater than 2 and this part converges for mod z less than half. So it means that in this case we don't have any reason where both are converging together. Why? Because see, I have to draw a circle of 2, radius 2, and the ROC is exterior of this circle of radius 2. So this is black region is corresponding to ROC of the first component. And for the second component, second series, what is the ROC? ROC is this region, this interior of circle of radius half. Now you can see you don't have a region where black and green colors are together. Green color is inside this circle of radius half and black color is outside this radius of circle of 2. So there is no common region where both the sequences are converging together. Though individually the sequences are converging for different regions, but they are not converging simultaneously and therefore this won't be the answer. Answer will be what? That Z transform does not exist. When it does not exist, when alpha is what? Greater than 1. So alpha to the power n mod n, its Z transform doesn't exist. If what? If mod alpha is greater than 1. Whereas if mod alpha is less than 1, the Z transform exists. So with this, I stop here. Thank you very much for watching my videos. Bye.